All right, so for this game, looks like we have what is essentially an in and out game. Now, it is a labeled in and out game, so we kind of have cars 1 and 2. But the way that this game is set up, the fact that everybody is going to go exactly once into one or the other car, turns this into what is functionally an in and out game. Now, the elements themselves, we've essentially got F, G, H, J, K, and L. And there is one kind of quirk that they throw into this. Apparently, for each one of these two cars, there's going to be exactly one driver, and each one of them is going to have at least 2 people. So we can kind of set up the spacing, the minimum 2 spaces each, and we can kind of also reserve that one of these in each car will definitely be driving, and that's kind of distinct. Anyways, from there, let's take a look. The first rule, either F or G must drive the car in which Hannah travels. Now this one's really easy to slightly misconstrue, but this doesn't just say that F or G have to go with H. It's more than that. One of F or G has to drive the car with H. So essentially, I guess we can do this as a conditional statement that if we have H, then we'll have to have either F driving or G driving. Next, one of F or K must drive the car with Juan. So if we have a J, then we're going to have either F driving or K driving. Now, actually at this point, we can kind of do a little bit of damage with this, because I suppose that means that H and J, potentially, they could be in the same car, couldn't they? But the only way that that would happen is if F is the driver, right? Because if H is with G who's driving, then J wouldn't be able to go there. So H and J could be in the same car together as long as F is the driver. But otherwise, if they have somebody else driving with them, right, then, so for example, if J is with K as the driver, then H would have to go into the other car, right? So there's really only 2 major plays for that. This isn't probably worth exhausting per se because we don't know which car is which, but essentially either H and J are going to be together with F driving the car, or otherwise they'll have to be in separate cars with whoever driving. Anyways, lastly, G must travel together with L, so we'll have to have a GL block on the board. So from there, I suppose for that last rule, it doesn't really give us too much. I mean, it's kind of interrelated to the H. G has to drive, and that would bring in L, but that's only, of course, if G is the driver for H. Otherwise, it's kind of flexible. So you know what? Let's take a look at the questions. So the first question here, as usual, is our standard exclusion question. So we go by the rules. The first rule was that when it comes to H, F or G has to drive. So let's see if anything violates that rule. A looks okay. H is with F driving. B, H is with F driving. C, H is with G driving, that's still good. D, H is with K driving, that's not cool. We can get rid of answer choice D. And E, H is with G driving, so that's good. Next, J has to be with F or K driving, so let's take a look. Answer choice A, J is with F, that's fine. Answer choice B, J is with L driving, that's not okay. So we can get rid of answer choice B. C, J is with F, that's legit. And E, J is the driver. That's not going to work. We can get rid of answer choice E. And lastly, G and L have to be together. Let's take a look. Answer choice A, they are together. Answer choice C, they are separated. We can get rid of answer choice C, and that leaves us with answer choice A as the best answer for question number 1. And I suppose, as usual, let's just quickly plug that into the board. So answer choice A says FHJ with F as the driver. And answer for car number 2, we have GKL with G as the driver. And from there, I suppose, let's take a look at the local. So the first local question that we have here is question number 3. Let's see what we can do. If L is the driver in one of the cars, now to be honest, car 1 and 2 doesn't really seem to matter in this game, does it? Not unless they're explicitly kind of being called out. So you know what, let's just kind of arbitrarily put Lisa into car number 1. So if Lisa is the driver, what does that tell us? Well, I suppose that means that H and J would not be able to go with her, right? Because H and J can't have Lisa driving, but that means that they're going to have to be together in the other car. And if they are together in the other car, then the only way they can be together there is if F is the one driving them. So that's a pretty good start. And of course, G has to go with L, so we know that G is definitely going to be in 1. Now, who are we left with? We have K remaining. And can we do any damage with that? And I suppose no, there's no real restrictions, and we've already resolved the minimum 2 each, so I think we're good. K could go either way. So the question asks, which of the following now could be true? Answer choice A, F goes with K. And yeah, I mean, K could go either way, right? So why couldn't? Answer choice A looks pretty good. Just in case, let's take a quick look at the others. Answer choice B, F is with L, and no, they're definitely separate. Answer choice C, G is with H. Nope, they're definitely separate. Answer choice D, G is with J. Nope, they're definitely separate. And E, H is with L, and no, they're definitely separate. So the best answer, once again, is answer choice A for question number 3. Next, question number 4. We've got if F is with 2 other people in car 1, and if F is not the driver. So we have quite a bit there. So F is going with 2 other people, so we have F plus 2 others, and she is not the driver, so the driver is going to be separate. Then, well, I guess, what does that tell us? What can we do with that information? Well, I suppose, first of all, if F is not the driver, that means that H and J are definitely going to have to be in different cars, right? And we know that, I guess, H is going to be with G as the driver for sure, and J is going to be with K as the driver for sure. Oh, but wait a minute. If H is with G as the driver, then they're going to have to be with L, so they're going to have an H, G, and L block, except we only have 3 people here in total, right? F is with 2 other workers in car number 1, which means that if we have H, G, and L together, they're all going to have to go in car number 2. And of course, G is going to be the driver there, which means now everybody else has to go into car number 1, which includes J, but J is not the driver, and K, who will be the driver. All right, so let's go. The question now asks, ooh, and this one's a bit of an annoying question stem. So the question is asking the person in car 1 other than Faith and the driver. Other than Faith and the driver, the other person is J in car number 1. The best answer choice here is answer choice C for question number 4. Next, we looks like we don't have any more local questions, so let's bounce back to the globals. Question number 2 says, the 2 workers who drive cannot be. So who can't be the 2 drivers? I guess let's take a look. Answer choice A, could we have F and G as the 2 drivers? And I mean, maybe, because if F is driving, then they could pick up H and J quite easily, right? And then G could drive with L. That in the other car, that seems okay. Next, F and K. And again, that seems okay. Like H, J could have F driving them. And K could be in the other car driving G and L, and that seems easily fine. Answer choice C, could we have F and L driving? And same kind of thing, yeah. If H and J are with F as the driver, then L could be driving G, and that seems okay. Answer choice D, could we have G and K as the drivers? And maybe that gives H a driver, and J would get a driver. And I guess L would go with a G, but that seems fine. Answer choice E, could K and L be the drivers? And no, that definitely can't happen because H does not have a driver, right? H has to be with one of F or G. So the best answer to question number 2 is E. Lastly, question number 5. What cannot be true? Let's take a look. Answer choice A. G is the only person other than the driver in one of the cars. So basically, could G be with just one other person, and the other person would be driving? Well, I suppose if that's true, then G would be with L, L would be the driver, and everybody else would go into the other car. But that seems okay, no? Because, I mean, H and J could have F driving them, and then, yeah, they would just pick up K as well, and that seems entirely fine. Answer choice B, could we have H be the only person other than the driver? Well, I suppose, actually, yeah, why not? As long as H is not with G, because if H is with G, then you'll have to drag in L as well. But if H is with F, then that could be the entirety of the car, and then everybody else would go into the other car. You would have J with K driving, and then G and L. That seems entirely fine. Answer choice C, could we have J as the only person other than the driver? And yeah, this one seems even more flexible in that sense, doesn't it? Because you could have J with either F or K as the driver, and then everybody else would go GL, you would have H, and whoever's left over, that seems entirely fine. Answer choice D, could you have K as the only person other than the driver? So I guess you would have K with exactly one other person there driving. Could that be okay? Well, actually, wait, who would that be? Because if there's only one other person, H can't drive, obviously, right? And J obviously can't drive. And it couldn't be G or L because they would have to be together. We can't have that because that's two people. And that's, I guess F is the only other person. So K would have to go with F, and F would be the driver. Oh, but that's not going to work because if you take away F, then H and J are not going to be able to go in the other car, because the only way for H and J to go together in the other car would be if F was the driver. So there's no way that this would work. So the best answer here is answer choice D for question number 5.